668 Div1. Um the problem statement in brief is that we have two participants, Alice and Bob. They're playing a game. Both of them initially have some position, that is, they are present at some node in the tree, and Alice moves by a distance A, has a stride A every time he moves, and Bob has a stride B. Sorry, Alice has a stride DA, Bob has a stride DB. A and B are their initial positions, and we need to find. We say that Alice has won the game if Alice is able to uh, reach at the place where Bob is standing, then we say that Alice has won. If Alice can never reach such a state, that is, Alice can never reach at the cell where Bob is currently present, we say that Bob has won. So if Bob can continue this process indefinitely, then we say Bob has won. The way we solve this question is by making a few observations. One observation is that uh, if, let's say, this was the case, and Alice had a stride 3, Bob has had a stride 5, then we can see that in the first stride, so Bob has a stride 5, right? 1 2 3 4 5. Okay, if ever reach a state when it's Alice's turn and Alice is present within a distance less than or equal to stride A from Bob, then Alice will always win, because in that particular stride, in that particular step, Alice will be able to reach Bob. So in this case, 2 3 4 5, yeah, if this is the initial configuration, that Alice is here and Bob is here, then in the first step only, Alice will move 5 steps at 1 2 3 4 5 and reach Bob, so Alice would have won. And but now, in the question it is given that Alice's position is this, Bob's position is this. So Alice knows that if ever he's able to reach this position, he'll be able, and it's his turn, he'll be able to corner Bob, he'll be able to win. But also, if Alice stays at this position, Bob will not move. The reason being, if Bob moves, let's say Bob moves here or here, then Alice will be able to reach him in the next move. So it makes sense for Bob to not move. If Bob doesn't move in this step, this process will keep continuing. That is, Alice will also not move, and Bob will also not move, and eventually Bob will win. So Alice doesn't want that. So Alice moves to this node, let's say. And the reason why it moves to this node and not to this node, we'll discuss that. Okay. Let's say Alice moves to this node. Bob has a stride 5. If Bob doesn't move, Alice will win in the next move. So Bob has no choice but to move. If Bob moves in this part of the subtree, then he'll lose. So Bob has no choice but to move in this part of the subtree, and he wants to get as far as from Alice as possible. So he'll move to this node. Again, Alice will want to maintain a distance 5, so Alice will come to this node. No, not to this node. Yeah, Alice will come to this node, because if Bob doesn't move now, he'll be able to get Bob in the next step. While Bob now moves to this node, Alice will move to this node. No, not this node. Alice will move to this node. Now we see that Bob is stuck. That if Bob comes to wherever, no matter how Bob moves, Alice will be able to catch him. So, upon doing a bit of casework, we can, upon solving a few examples, drawing a few examples, you'll be able to notice that whenever the stride length of A, so the first case is if initially the distance of Bob and Alice is less than SA, Alice will win. This is a trivial case. Now we move on to the case when uh, initial distance between Bob and Alice is greater than SA. If this is the case, if this is the case, and if this is the case, and if SB, stride of B, is less than or equal to 2 times stride of A. If this is the case, we say that always Alice wins. The reason being, let's say we have this configuration, stride of A is 1, stride of B is 2, right? So SB is less than or equal to 2 times SA. If Alice was here initially, Bob was here initially, Alice moves here, Bob moves here, so Bob is here, Alice is here, Alice now moves here, so Alice is here. Now Bob has no. Okay, Alice moves here, Bob moves. Bob doesn't move now. Alice moves here. Now, no matter how Bob moves, if Bob moves 2 steps here, or if Bob moves remains in his place, Alice will anyways be able to win. So, upon doing a bit of casework, you'll be able to see that this leads to failure for Bob. So, if um yeah, so if this is the case, we can conclude that always Alice wins. Also, but if this is not the case, that is, if SB is greater than equal to 2 times SA plus 1, even then we won't be able to guarantee Bob's win. The reason being, let's say that stride of A is 1 and stride of B is 5, but the tree itself is limited. That is, the tree is this size. Alice is here, Bob is here, Alice moves here. What can Bob do? Nothing. So if the diameter of the tree itself is less than or equal to 2 times SA, even then Bob won't be able to win. Even then Alice will win. 2 times. Even then Alice will win. So yeah, but if all the conditions are satisfied, only then Bob wins. So this is a bit of casework, and looking at the code, this is the initial condition, trivial condition check. Then we see what is the distance initial, distance uh, what is the initial distance from A to B. If the distance from A to B was is less than equal to SA, Alice will naturally win. um, okay, once this is handled, we'll see the diameter size of the tree. If the diameter size of the tree is greater than equal to 2 times SA plus 1, only then would Bob be able to win, otherwise Alice would win. This is a simple DFS. This is the solution.